Hello, and welcome back. We're going to be looking at how to deal with the data that we get um, and how to actually start mathematically applying statistics to the things we do. And so, what we're going to have to do is we're going to have to look at our measurements. Very early on, we're going to come into some different concepts with numbers. So for right now, I want to just look at some things a little bit ahead of the book, and it's about sets of numbers. Now we're going to find that there's different ways we can measure some variable of interest in reality. And a lot of the times you're going to see me talk about a population using area. And I'll talk about all possible things are in the rectangle, and the sample I grab is within, right, of some variable of interest. Let's say this is all people in, let's say Massachusetts. We'll keep it local. And I grab a sample to measure some variable of interest. And that variable of interest is the thing I'm measuring, and so let's say height. We'll measure everyone's height. And so this is what we see coming across. We don't see everyone, the whole population. We see what we've grabbed from our sample. And so we use this geometry as a visualization to discuss everything we can grab and the things that we've actually been able to measure. And in that, our measurements come in different ways. So of all the people in Mass, I could look at their height. That could be one variable of interest. But also look at their eye color or age. Right? There are different variables of interest I could grab or measure if I had a sample. And one of the things that happens is the numbers we have invented have different purposes. So if I were looking at eye color, I would get categories of blue, green, brown. I think these are the three main eye colors. I know there's no reds. And we would have to count. We would count the number of people with the different eye colors from our sample. And counting numbers are kind of the first set of numbers we have, and they do a neat thing. Counting numbers come in gaps. So if I were to start at 0 and work my way up, creating a number line, when I count things, I can't have less than 0, no less than 0, and I can't have anything between 0 and 1. Right? I don't have 0.5 people with blue eyes, and David Bowie not included here, and I don't have 1.5 people with brown eyes. It's either a 1 or a none. And so counting numbers come across, and these are called discrete numbers. And you're going to find that counting is a thing that we do. Well, it means the boundaries of when we deal with numbers are very specific for discrete numbers. Well, if I did height, change color here, and I will bring up height. So if I did height, right, and I go through and I grab the height of people in here, there are different heights these people could be. And so if I do my number line again, we're going to find that people kind of start around 4 foot. Well, we'll turn it into a decimal for now. We won't use inches. Like 4.5 feet to 7.5 feet. We'll find that most people are in there somewhere, but they can be any range. You have 5 foot, 5.8 feet. You have 5.874 feet, and you can have this range of numbers. And so we're going to have to pay attention to how we define the different types of numbers. And these are called continuous numbers. We can always wedge a number in between them. They're smooth. There's no gaps. And so we're going to have to keep this in mind as we build our tools that our tools are going to function slightly differently depending on the set of numbers we're using. If we're using discrete numbers, or in this case, these are real numbers. Right? And from the old set, these are real numbers, and these are the whole numbers. And this goes back into when we were talking about the different ways we had to measure. All right, so we'll keep this in mind. The other thing to keep in mind is in all of this data that we're now going to be processing, we chose how to get the data, we chose the variables that we're measuring, and so that choice is going to be reflected in the things we can see. And that is, in the end, the ultimate nature of a bias, is the choice of what we picked. But the first thing we're going to want to do is we're going to want to talk about how numbers or how data comes across. Now, if I go back to my idea of here's some population, how data comes across, sorry for the half sentence here. This happens when I'm trying to kind of look at my notes and then kind of transition. I have my sample coming from some population, and I get data from it. Now, the data comes across randomly based on the person I'm looking at or the thing I'm measuring, the object I'm measuring. And so I'll have a set of numbers of whatever the variable of interest is. So for right now, I'm just going to call that variable of interest x. A lot of times I'll say x sub I so that I talk about the first one. Well, let me make a set here. I'll show you what I mean. I'll bring the language. 4, 8. And so here I've measured 1, 2, 3, 4, 5 things, and my measurement has these numbers to them. And so the first variable of interest is 10, the second is 15, the third is 12, the fourth is 4, didn't try that, and the fifth is 8. And so this little subscript tells me which one it is in the set. Generally, order isn't important. I could randomly pick in here, so the order that I get from these things isn't important. And so what we like to do a lot of the time, and I'll change color to show this, is we like to arrange our data in order from the smallest to the largest, so that we can see how these measurements fall into number lines or into groupings, and we call that the distribution. And so we'll tend to order our data so that our data is in order, and we can look at this, and by putting it in order, I kind of notice things are more over on this side, right? I have very few things down by 0. If I were to put it on a number line, and start with 0, there's all 15, that's 15 marks, so I have a piece of data here, piece of data here, piece of data here, piece of data here, and a piece of data here. I have more stuff over here than I do over here. And that's going to have some meaning depending on what we measured. In fact, most of this chapter is trying to get some meaning out of where our data sits. And so we can think of it positionally from the smallest, x min, to the largest, x max. Again, I'm using x to talk about the variable I've measured, and we can talk about different variables. For right now, I don't want to call it anything particular. I just have something I measured out of this population. I grabbed some samples. I grabbed 5 samples, so I'll tend to talk about n equals 5. Means I grabbed 5 samples, and the minimum was 4, and the maximum was 15. And so I'm already taking information I've collected and I'm organizing it so I can look for patterns. And this is so common, it sometimes doesn't get talked about a lot. What we then do is we'll talk about how often numbers appear in our data. And that's the big goal of this chapter, is to look at how often or how frequent numbers appear. So how frequent, which we use the thing called frequency. Where most of the things are. Right? Like I said, most things are over here. And we do that looking for middles. And the middles we have will be median, mode, and mean. And the mean is going to be the one that we'll talk about a lot. And these are the middle of our data, and we'll have ways of calculating that. And then we want to figure out how bunched up it is, or how it varies, how the data varies. And that's called variance. And so what we're going to do is we're going to borrow geometry. We're going to borrow the rules of geometry, and we're going to turn our data into graphs. I already started here by lining things up on a number line and seeing things are condensed towards one side of a number line. And so I'm borrowing geometry to look for where most of my data is. And we're going to really want to work on those terms. And so chapter 2 starts off with really understanding frequency and how to graph the data. So some things to keep in note. I'm going to close this little video out and expand. Section 1 has a couple of small videos in it. Is we're going to be aware that we're going to be turning our data into numbers. And there's going to be different types of numbers. And the two different types of numbers are discrete, which are our counting numbers, or the integers, and then real numbers, which we call continuous because, I can always measure a little bit better. I can always squeeze another number near it, and these are two different numbers based off of how well we can measure. And they're going to affect the borders we can see with our data. And so we just have to be aware of that as we move through other things. All right, so I'm going to continue with Chapter 2, Section 1, and we're going to look at frequency specifically. And we're going to talk about frequency distributions. See you in the next video.